Hello everyone, this video is about uniformly accelerated motion. So what is accelerated motion? Accelerated motion is a non-uniform motion, which means that the velocity is changing. So if the velocity increase or if the velocity decrease, we have acceleration. And uniformly accelerated motion means our acceleration is constant. It does not change. So the velocity is changing, but the acceleration is constant. So here we assume that the acceleration is constant and the motion of an object is along a straight line. So what are the equations of uniformly accelerated motion? So here we have some equations. So the following equations apply to uniformly accelerated motion. The first equation is v equals v naught plus at. So v is the final velocity, v naught is the initial velocity, a is the acceleration, and t is the time. The second equation is x equals v naught t plus half at squared. So here x is the displacement. The third equation is v squared equals v naught squared plus 2ax. And the fourth equation here we have v naught plus v over 2 and the whole thing multiplied by t. So in this case, v is the final velocity. In meters per second. And we can write meters per second also like ms to the power of -1. V naught is the initial velocity. In meters per second. A is the acceleration. In meters per second squared. And we can write meters per second squared also like this, ms to the power of -2. T is the time in seconds. And x is the displacement in meters. As we can see, there is arrow on top of letter V. There is also an arrow on top of V naught, A, and X. Because the final velocity, initial velocity, acceleration, and displacement are vector quantities. They have direction, and therefore we put an arrow on top of these letters. And we don't have an arrow on top of letter T because T is time. It doesn't have direction. Time is scalar quantity. It has magnitude only, no direction. Alright, so let's look at some examples. So let's look at here question 1. A train starts from rest and accelerates uniformly at 1 meters per second squared for 10 seconds. Calculate the final velocity. So in this case, we need to know the value of v. What do we have? So let's underline the keywords from rest. This means that the initial velocity is equal to 0. We also here know the acceleration, 1 meters per second squared, and we know the value of t, 10 seconds. So in this case, which formula do we use? Let's look at the first equation. I want to know the value of v. I know the value of v naught. I know the value of a. I know the value of t. So yes, we can use the first equation to find the value of v. So here v is equal to v naught plus at. V naught is 0 because the train starts from rest. So from rest means that the initial velocity is 0. So the initial velocity is 0 plus acceleration is 1 and the time is 10. 1 times 10 is equal to 10 meters per second. So therefore, the final velocity is equal to 10 meters per second. In this case, if the train is moving to the right, then the velocity would be to the right as well. The final velocity, the direction would be to the right. Okay, part B, let's find the displacement in 10 seconds. So here, which equation do we use to find the displacement, to find the value of x? So let's look at the second equation. I know that v naught is equal to 0, so v naught times t is 0. I know the value of a. I know the value of t. T is equal to 10 seconds. So therefore, we can use the second equation to find the value of x. So here, let's use the second equation. X is equal to v naught t plus half times the acceleration times t squared. So here we can put arrows, guys, on top of v naught and a. Okay, so as we said, the initial velocity is 0. 0 times 10 is equal to 0 plus half times the acceleration. The acceleration is equal to 1 and the time is 10, so t squared. So we have here 10 squared. 10 squared is equal to 100. 100 times a half is equal to 50 meters. Again, if the train moved to the right 50 meters, then the displacement would be to the right. But in this case, we don't know the direction of motion, so we can just leave it like this. Alright, so now let's look at the next question, question 2. A truck accelerating uniformly reaches a speed of 3 kilometers per hour from rest in 30 seconds. Calculate the acceleration of the truck, give answer in meters per second squared. So as we can see here, we need to convert the velocity from kilometers per hour to meters per second. So the final velocity is equal to 3 kilometers per hour. So 3 kilometers per hour is the same as 3 times 1 kilometer per 1 hour. So here we want to convert kilometers to meters. So we need to multiply 1 by 1,000 because there are 1,000 meters in 1 kilometer. So here 1 kilometer times 1,000, this will give you a value in meters. And now we want to convert 1 hour to seconds. So 1 hour times 60 because there are 60 minutes in 1 hour. And now we can convert from minute to second. Again, there are 60 seconds in 1 minute. So to convert from minutes to seconds, we need to multiply by 60 again. Okay, so now this is the same thing as 3 times 1,000 over 60 times 60. And we get, so let's use the calculator and determine this value. So 3 times 1,000 over 60 times 60, we get 5 over 6 meters per second. Alright, so this is our final velocity. So we know the final velocity, again from rest, that means the initial velocity is equal to 0. The time is 30 seconds. So here, which equation do we use to find the acceleration? I think we can use the first equation because I know the final velocity, I know the initial velocity, and I know the time. So in my previous video, we calculated acceleration and we said acceleration equals change in velocity over time. So change in velocity is v minus v naught, that's change in velocity over the time. And that equation is the same as this equation, but here we are making v the subject. So to make a the subject, acceleration equals the final velocity minus the initial velocity over the time taken. So the final velocity is 5 over 6 minus the initial velocity is 0 from rest over the time, and the time is 30 seconds. So 5 over 6 divided by 30 is equal to 5 over 6 times 1 over 30, and that equals to 1 over 36 meters per second squared. Which is approximately equal to 0.0278 meters per second squared. Alright, so now let's look at question B. calculate the distance traveled in this time. So let's find the distance. So which equation do we use to find the distance? So in this case, if the truck is moving to the right, the distance and the displacement are equal. They are both the same. Okay, because the displacement is from the starting point to the end point. So they are both the same thing. So in this case, when we tell you to find the distance, that means just find the displacement, which is x. So which equation do we use? So let's look at the second equation, because the second equation has x. So do we know the value of v naught? Yes, we know the value of the initial velocity. We know the value of t, and we just calculated the acceleration in part A. So yes, we can use the second equation to find the value of x. So let's write down the equation first. Displacement equals initial velocity times the time plus half times the acceleration times t squared. Alright, so what is the initial velocity? The initial velocity is equal to 0. So you have 0 times 30, which is 0, plus a half times the acceleration. I will just write it as a fraction in exact form. 1 over 36 is the value of acceleration times t squared. So times 30 squared. And here we can just use the calculator and calculate the value of x. So we have a half times 1 over 36 times 30 squared. And this equals to 12.5. So the value of the displacement or the distance is equal to 12.5 meters. Alright? Okay, so now let's look at the next question. A steel ball is thrown vertically upwards with an initial velocity of 5 meters per second. Calculate the maximum height reached. So now we are dealing with vertical linear motion. And vertical linear motion is motion of an object near the Earth's surface under the influence of the force of gravity, which pulls the object towards the Earth. So the Earth's force of gravity gives the object a constant acceleration of 9.8 meters per second squared towards the Earth's surface. So now we take the value of A to be 9.8 meters per second squared downwards. Okay, so here to find the maximum height reached, we need to know a few things. If the object is going upwards, and in this case the object is going upwards, vertically upwards, therefore the object will stop at maximum height and then it will come back down. So therefore the velocity at maximum height is equal to 0. And let's say if it took 3 seconds to reach the maximum height, it will take 3 seconds to come back down to its original position. Alright, and we take all upward directed quantities to be positive and all downward directed quantities to be negative, including the acceleration due to gravity, because acceleration due to gravity is downwards, therefore the value of A would be negative 9.8 meters per second squared. And if the object is just going down, here we know the initial velocity is downwards if it's not equal to 0. The final velocity is downwards. The displacement is downwards because the object is moving downwards. And the acceleration due to gravity is downwards. Therefore, we can just take all quantities to be positive to simplify the calculations. And at the end, we know that the direction of each vector quantity would be downwards. Alright, so in this case, we are looking at the first scenario because the object is traveling vertically upwards. It will stop at a certain height and it will come back down. So what is the maximum height? In this case, I want to know what is y. So instead of x, now I'm just putting y because now I want to find the vertical distance. So here instead of x, we can just put y. So what is y? So let's look at these equations. Can I use the second equation? So I want to know the value of y. I don't know y. I know the initial velocity, but I don't know the value of t. So I can't use the second equation. So maybe we can try the third equation. Do I know the final velocity? Yes, if you consider only half of the journey, because we just need to consider half of the journey where the object reach its maximum height. So we can use 0 for final velocity. Initial velocity is given. Acceleration, we know the value of a, and I want to know the value of x. So yes, one unknown, we can just use this equation to find this unknown. So let's make x a subject, but I will just write here y instead of x. So y is equal to final velocity squared minus initial velocity squared over 2 times the acceleration. And you can also put the arrows on top of v, v0, and acceleration. And now we can just sub in the values. So the value of v is 0, so 0 squared is 0, minus initial velocity is given 5, so minus 5 squared over 2 times the acceleration due to gravity. So here, because we considered only the first half of the journey where the object is moving upwards, therefore a would be minus 9.8. And now we can just use the calculator and determine the value of the maximum height. And the answer is 1 point. So I'm just gonna round the answer to 2 decimal places. So I got here 1.2755. So this equals to 1.28 meters. Don't forget the units. So the unit of the maximum height would be in meters. Question B, calculate the total time of flight. So in this case, I will first calculate the time it took to reach the maximum height. So I will just call T up. And then once I know the value of T up, then I can calculate the total time. Because I know T up is the same as T down. So just 2 times T up. Alright, so what is T? So maybe I can use the first equation because I know the final velocity, I know the initial velocity, I know the value of acceleration due to gravity, and I want to calculate T. So T is equal to V minus V naught over A. Okay? And this T, I will just call it T up. So let's sub in the values. The final velocity is 0. The velocity at maximum height is 0. The initial velocity is 5 upwards, so minus 5 over the acceleration. The acceleration is negative 9.8. So calculate this, we get, so minus over minus cancels out, so we just have 5 over 9.8, and we get 0.51 seconds. And therefore, the total time of flight would be 0.51 plus 0.51, or we can just say 0.51 times 2, and we get 1.02 seconds. Question 5. A soccer ball thrown vertically upwards takes 8 seconds to come back to the ground. Calculate the initial velocity. So what is V naught? Alright, so first step, let's quickly sketch. So the object is going upward, it will stop at maximum height and then it will come back down. So if it took 8 seconds to come back to the ground, therefore it will take 4 seconds to reach the maximum height, and it will take 4 seconds to come back down from the maximum height to the ground. We also know that the velocity at maximum height is equal to 0, and we want to calculate the initial velocity. We don't know the value of the initial velocity. So which formula do we use to find V naught? So in this case, let's start with the first formula. So I know the value of V, the final velocity is 0. So if we just consider half of the journey where the object is going completely upwards, we know the final velocity at maximum height is 0. Initial velocity is unknown. Acceleration due to gravity, we know it, 9.8. And we know the value of T. It took 4 seconds to reach the maximum height. So let's use the first equation and find the value of initial velocity. So V is equal to V naught plus A times T. Let's make V naught the subject. So V naught equals the final velocity minus AT. Let's now sub in the values. The final velocity is 0 minus the acceleration due to gravity. So we said if the object is moving upwards, then we can just choose that all upward directed quantities are positive and all downward directed quantities are negative. So here we can just say A is negative 9.8 minus 9.8, and the time it took 4 seconds to reach the maximum height. 9.8 times 4 is equal to 39.2 meters per second, and we know that the direction of the initial velocity is upwards, so we can just write here upwards.